Hey, my name's Justin. I'm a Salesforce developer from the US. And today we're going to build an entire Salesforce to Jira integration that I use for my business from scratch. This uses some of the latest tools from Salesforce, including Lightning Web Components, named credentials, and Queueable. But what are we building? Well, I want to have my support process managed in Jira and my sales process managed inside of Salesforce. We want to be able to kick off our support process in Jira using the data we have in Salesforce. This means that we have a wizard to enter the necessary data for each project and verify the data from Jira. Every opportunity will be associated with a version. I use opportunities as SOWs, so each version fits nicely. We can create a version inside of Jira with a simple wizard. And all issues from Jira will be associated with a case inside of Salesforce. We can link back to the opportunity and account with the related project and version IDs. Issues will have an option for a one-time sync as well as a scheduled sync. I will walk you through every step of the way on how to build, architect, and organize your project. There are timestamps below for your convenience. With that out of the way, let's talk about the tools we need. First, we will want admin access to both Jira and Salesforce. Additionally, we need the Enterprise Edition of Salesforce to write Apex code. For the environment, I'm going to be using VS Code with the SFCLI extensions. I will also be using Postman to simulate REST callouts. We also need a Salesforce org to do development. I'm going to use a developer org to store this data. You can go to developer.salesforce.com to get a free Salesforce org for this tutorial. To start new Salesforce projects, I like to use this new org template I created. Go to the GitHub repo and you can clone for your local development. This will contain the project structure as well as some extra add-ons to go and make Salesforce development simple. We can then clone this repo and use Git to bring the actual code to our local machine. Then we can open in VS Code accordingly. Now we can go ahead and authorize our org. We can use the SFCLI extensions by going to authorize an org, selecting the associated URL, in this case login.salesforce.com, give a nice alias. We'll go ahead and open this in the browser and log in accordingly. And now we have everything set up so we can start doing everything we need to build out the project. The first part of any integration is authentication. In this case, we're going to be using basic auth because I want to keep it simple. In general, basic auth functions by passing a username and a password inside an authentication header. In the case of Jira, we're going to pass in our email as the username, as well as a token we get from Jira, which we can generate inside this URL. From here, we can go and generate the API token, give it a nice name, as well as save it for later. Inside of Postman, I have a sample request set up. You can see we have a username and password under the basic auth type. When we send the details, we get the related data from our Jira instance. Now let's go inside Salesforce and set up the named credential. Inside of setup, we can search for named credentials and we can go to the external credentials tab. We can give it a name like Jira external credential, and we'll want to use the authentication protocol as basic authentication. We can use principals to set up the authentication at a per org basis or a per user basis. Setting this to named principal will put this at a per org basis. We can then copy the username and password as needed. Now let's go ahead and set up the named credential, which will allow us to use this authentication details inside of Apex. We can go back to the named credential tab, go and create a new named credential. Here we'll give it a name. In this case, I'm going to call it Jira. We need a URL to make all the endpoints. In this case, it's onesync.atlassian. Keep in mind that the onesync is your Jira organization name. And then we'll want to select the Jira external credential, and we'll want to ensure that the authorization header is generated. Now we want our users to be able to run this. So we're going to go to permission sets, and we're going to create a new permission set that will contain everything any user needs to run this. We can go and create a new permission set, call it Jira Integration. We don't need a license in this case. The permission that we need to set is the external credential principal access, quite a mouthful. And we're just going to go ahead and move this as active. Additionally, you'll want some users who aren't system admins probably to run this. And the easiest way to go and do this is inside the object settings, we can go to user external credentials and make sure that the permission set has read access to this object. From here, these are all the basic permissions. Of course, any fields that are created, we can go and add as needed for field permissions. And finally, we'll just want to go and assign this to any users. So I'm going to go ahead and assign this to myself. So now that that's out of the way, let's go ahead and jump into the Jira documentation. So the first thing that I want to be able to do is create a project from an account. You can see the documentation here. And there's a few things that we need, which are required fields. So we'll need a key as well as a name for the project. This isn't required in the documentation, but we'll also need a project lead ID. And keep in mind, this is going to be a post request, so we'll send to this project URL. And here we are inside of Postman. I have this sample request set up, and you can see how this request works. And inside of Jira, you can see that related data. Also note that the sample request that I had earlier is how I got the user ID. Inside of VS Code, let's go ahead and create a new class. We can call it Jira Callout, which is how I like to go and store all of my callouts for a given service. Then we can go and create an HTTP helper method. This will take in parameters like the body, the endpoint, and the method. The purpose of having a method like this is to abstract away all of the same code that we're going to go and send the body and send any request details to using the named credential. As well, we can add some java.comments to quickly add details on what each parameter is. Next, let's go ahead and instantiate the HTTP object as well as the HTTP request object. These are both standard objects that we use to go and send data from Salesforce to third-party services. Next, what I like to do is I like to set the endpoint, and here's where we go and use the named credential. We have this callout and then the callout name, and then we can add the endpoint variable from our HTTP helper method, which will make this dynamic. Additionally, we'll want to go and send this, so we can create the HTTP response object and send using the HTTP object and send the request. A few other things that we'll need to add. First of all, we're going to go and debug the output, right? So we can get the body using the getBody method, and that will allow us just for simple debugging. We'll also want to go and return an HTTP response, which will just make this callout much easier. So let's change the return type from void to HTTP response. Additionally, we want to set the method like get and post. And one final thing I like to do is if there's a body, we set this. Otherwise, we just keep it as, well, we don't set a body. For the get methods, for instance, I like to just pass in a null value for the body. Also, we need to let Jira know what data we're sending. So in this case, we're going to set a header of the content type, which will be the application/JSON, because we're going to be sending JSON values. So let's go ahead and deploy this, and you can see that everything compiles, and we can start using this for all of our methods. So let's go ahead and create our first method that uses this. So I'm going to go ahead and create a static method that has the HTTP response, and we're going to call it create project. And for this, we want to just take in the body as a string. We also will want to return the HTTP helper, and we can set the endpoint as project. We can set the method as post, and the body we already have set. Let's go ahead and add a few java.comments. So we can have this param be the project body. So let's go ahead and deploy this so we can start using this in other classes. So one of the things that we need to do inside of integrations is we need to take data from Salesforce, and we need to be able to serialize that as a JSON object. And so what I like to do is I like to use this website called JSON to Apex. So the way that this website works is we can take the JSON from the Jira documentation and give it a name, and we can download a zip file. So I'm going to go ahead and unzip this file. I just use the command line UZ tool. And when you open the file, you can see that there is a class called Jira Project JSON. And this contains class variables that we can use to read and set data inside of Jira, as well as a parse method to get the data from Jira. So let's go ahead and create the actual class inside of Salesforce, and then we can copy the data. Additionally, there is accompanying test code. So what we can do is open the test class, go ahead and copy the name, create a new class using the name, and then copy the data. And we can go ahead and deploy it, which should help us get to the coveted 75% test coverage. So the way I want to have this architected is that we have an account from Salesforce, and each count will be represented by one project, right? So to create this abstraction, let's go ahead and create a few classes. Now I'm going to create a class called Jira Project Helper, which will just go and wrap all of our code to make it one simple place to run everything. So let's create a new method that will return an account where we go and call this creator update project. We'll get the update part later on, but we want to pass in an account, and we will also want to pass in the user ID, which will be the user ID from Jira. We'll call this project lead ID. And obviously we want to just set a return type of null so that then we can go and deploy this. So now we have a few classes created, and honestly, it's getting a little messy here. We only have 6 classes, but I think it's a good time to introduce the organization method. What I like to do is create a general folder for the callouts. So I call it callout, and then every additional endpoint, I go and create a folder. So in this case, we have the project folder. And then all of the wrapper classes that I use for parsing JSON, I have in a subfolder of that endpoint. So in this case, we have the Jira Project JSON inside the wrapper folder. And then the project helper, the controller, and any other classes that we need will all stay in this top level project directory. Now, we also need to map the account data to the Jira Project JSON. So let's go ahead and create a class, and we'll call it Jira Project Mapping. And you can see we just go and can create this class inside the project folder directly. Let's go ahead and remove this sample code, and let's go and create a new method. So we'll want to return the Jira Project JSON, and we'll call this map account to project, try to be a little bit descriptive. And as a parameter, we want to take in an account. We'll also take in the project lead ID, which will be the Jira user ID, which we'll get later on. So let's go ahead and instantiate the Jira Project JSON. What we want to do from here is all the properties on the JSON, we want to map to a data field from the account. And so I'm just going to go ahead and go into Salesforce and create a few new custom fields. We're inside of Salesforce. We can go to the object manager and then the account, and we want to create a few fields, right? So let's go ahead and create a field of a text type. And this will be called Jira Project Key, which will allow us to go and store the Jira key. And we want this unique because you can only have one key per Jira instance. We'll want to create an additional text field that will be called the Jira Project ID. This is going to be an external ID and unique, which will go and store the numerical value of the ID inside of Salesforce. Next, let's go ahead and create another text field. We're going to call this Jira Project Name, and this is going to store the name of the project. Now, we could use the account name, but generally the account name is like Acme LLC, and we want to just have Acme, for instance, as the project name. And finally, let's go ahead and create a lookup relationship to the user, which we'll use as the project lead. So we'll assign the project lead on the account, and then we can get a project lead ID from the user later on. So with all the fields created for the account, let's jump back into VS Code and we can start assigning properties to the objects. So we can have the name be the account's Jira project name. It looks like autocomplete isn't working here, so you can go and refresh the S-object definition and potentially restart VS Code. Next, let's go ahead and assign the lead account ID, which will be the project lead ID that we have as a parameter in the method. We can go and have the project type key be hard-coded to software. Check the docs for this. I just prefer to create software projects in Jira. We can have the key parameter be set as the Jira project key that we created. And then we can go ahead and return the object we just instantiated. And let's go ahead and deploy to confirm that everything compiles. Back inside the project helper class, we can go ahead and create the new object instantiation. So let's go ahead and create a new project JSON called project. And let's get this by going to the mapping file and map the account to the project. And we already have the parameters set. Next, let's go ahead and get the HTTP response from the Jira callout class. So we can instantiate a response object and get this from the callout.createProject. And this method takes in a string as a parameter. And so what we want to do is we want to use the JSON.serialize method to turn our object into a JSON string so that then we can send it to the third-party system, in this case, Jira. And the second argument will ensure that if we don't set a field, we're not overwriting data inside of Jira. And you can see here, it looks like we forgot a semicolon as well as the create project method is private. So we'll add the semicolon and then we can go inside the callout class and make this public. And then we can go and deploy all of our code to Salesforce now that all of the references have been cleaned up. And now that we have the rough skeleton working, now is as good a time as any to ensure that all of our data and name credential and call helper and everything else works properly. So let's go ahead and go inside of Salesforce and create a new account record. I'm just going to call this Acme LLC. And we can go and fill out some data. We can just quickly add a key as well as the project name. We will also need the account ID for a SQL query. So let's just go ahead and grab the account ID from Salesforce Inspector. If you don't have this tool, you can grab this in the URL. Then inside of VS Code, let's go ahead and create a new folder called scripts. And we can add a .apex file, which will basically just allow us to run code in execute anonymous, but it's a great way of storing this code for more than one use. So just pasting the account ID here, and what we'll want to do is we'll want to get this account data using a SQL query. And so I'll just go ahead and create the base query using the account ID as the string filter. And we'll also want to go and query all of the fields that we'll be referencing. So in this case, it'll be the project ID, the project name, and the project key. So let's go ahead and run this. So we're going to use the Jira project helper class, and we are going to create our updated project. We can pass in the account that we just queried. And once again, I'm going to use the user ID that I copied from the demo. Keep in mind that you'll need your own user ID, so you'll need to set up the Postman call for the demo. And whoops, I forgot to add the project name for the SQL query. So we can go ahead and add that to the SQL query, and we can run this again. And you can see that we created, because we have this data of the ID and the project. And we can go inside of Jira, and we can see just exactly this data created with the project lead. Perfect. So I'm glad we created a project, but we want to be able to write the ID back into Salesforce. So inside the Jira project JSON file, let's add the ID as a field. And then what we can do is we can actually pass the response JSON as a parsed value of the class. So we can use the Jira project JSON.parse method to actually get the response data into values that we can use inside of Salesforce. And then we can go and record the project ID as the project response.id. And then we go and return the account. So back inside our script, let's go ahead and run this again. And we'll actually run into a problem here, which is that the project key already exists, as well as the project name. And so what I actually want to do is I want to throw an error if Jira throws an error. So inside the helper class, we'll just say if the status code does not equal 200, which is the status code of a successful project create, then we just want to throw an error that will go and capture the response body. And the best way of doing this is actually creating a custom exception class. So I'm going to call this here. But what we're going to do is this wouldn't compile. So let's go ahead and create a new class, Jira exception. And what we can do with this class is we can go and extend the exception class. And this will be a short class. But what this allows us to do is obviously have a custom exception type, as well as we can pass in these custom messages so that then we can go and alert ourselves when things go wrong. So this is my preferred way of handling exceptions with integrations. Now, when we go and deploy, we can see everything works fine. And if we go back to the scripts file, you can run and see that we'll actually get the exception inside the debug logs. So we have the stack trace thrown because we threw an error. Perfect. And we can catch this later on as needed, but this is how I like to do things. Now going back to the original problem, we want to go and update a project if it already exists. So if we have the ID, we want to update. So we'll create if there's no ID, and we'll update if there is a project ID. So we can simply check if the string is blank to see if the project has been created or not. And let's go ahead and throw this in the if statement. And if it's not blank, then we want to update the project. So we'll make a new method called update project, which will take in the project ID, which we'll use in the URL, and we will put in the body of the project JSON. And one other thing, since we now have this in the if statement, we're going to be dealing with variable scoping. So we can move the HD response out of the if statement, and then we can assign the value of the variable based on if it's an update or a create call. And inside the callout method, we're going to go and implement the create project. We basically do the same thing, right? So we want to add an additional parameter for the project ID. Technically, according to documentation, this could also be a key. So we'll add that in the documentation as well. And we want to call this update project and add the parameter of project ID. Then we add the end of the URL, we'll add the project ID, and we can go ahead and deploy, and everything should be good to go. Now let's go ahead and add the project ID, which in this case was 10,030. So if we look at the output of the execute anonymous, we can look and see that we have the 10,030 from the first run. So we can go ahead and execute anonymous, and what's this? We're getting an error. Why are we getting this error? So one of the reasons why we're getting an error is because a successful update call is a status code of 200. So let's just ensure that the status code does not equal 200, and that should fix our issue. So we can go ahead and run this, and we can see, we still get an error. What's going on here? So whoopsies, this also needs to be a put, not a post for the method because it's an update call. Final time, let's go ahead and run this. And well, would you look at that? We have all of this data. So this is a successful update call. So it's great that we can run this from the command line, but you're most likely not going to have end users running this from the command line because that's not going to happen. So what we can do is we can create a controller extension for the account. Now, I have a snippet here that creates a lot of boilerplate for a controller extension. You can check the links in the description for this extension. But what we'll need to do is we'll need to set up a lot of the same code we had for the script. So let's get the project key, project ID, and project name. We'll also rename this method to create project. I also like to have this page reference return to the existing record because that works better as a refresh method. So now let's go ahead and add the code we had in our script. So we use the project helper and we pass in the account. And once again, we're going to use the hard-coded ID. And then we want to go and update the account so the ID actually gets written to Salesforce. And because we're using the controller extension pattern, we need to create a visualforce page. So I'm just going to call this Jira project VF. We'll just use the standard directory and we will go and add all the necessary components. So we need to set the standard controller as the object name. So in this case, it's going to be account. We'll want to set the extension as the class we just created, and the action, which is what gets ran when the page is loaded, as the method we just created. We'll go ahead and deploy this, and you can see that we have a new Visualforce page created. So inside of Salesforce, let's go to the account object, and we can go to buttons, links, and actions, and we can create a new action. We will want the type as Visualforce, and we want to call this push project to Jira. And then what we can do is we can go and add this to the associated page layout as an action. So we can go to actions, and we can drag this to the page layout. We'll go ahead and save this. And when we go back to the account, we can see this button newly added. So we can run this and see that there's no error. Great, works perfectly. And just to confirm it works, let's go ahead and change the name, and we'll add a few T's, we'll push it again. And inside of Jira, we can refresh the page and we can see that the project name has been updated. So this is working just as expected. Now let's go ahead and remove the ID and test the error functionality. So we'll remove the ID and you can see we have error message. So works great. Now that we have the ability to create projects, it's time to get the user ID, but dynamically inside of Salesforce for every user. So we're inside the Jira documentation, and we can see here the find users by query, and this is the original call we used. Now, the way that this query works is that we take the email address as a query parameter, and we can go and search. And here we are in Postman running that exact call out. You can see we receive a JSON body with the account ID, which we'll want to write for later. Inside of Salesforce, let's go ahead and set up a few things that we'll need. So let's go to the user object, and we're going to create a new field to store that user ID. So this is going to be a text field. We'll call it Jira user ID, and we'll want to ensure that this is external ID and it's unique. Now we need a wrapper class to go and parse the JSON inside of Salesforce. So let's go ahead and copy this JSON from Postman, go into JSON to Apex, paste this, and we'll call this project JSON. Save this to our project, and then back inside of VS Code, we can go and again, open the terminal, unzip this using the UZ tool. And when we open the file, we'll see a almost ready to go object. Now I'm going to go ahead and create a class, but before we do that, let's go and set up the project structure. So we'll create a new directory called user for the user endpoint. And additionally, we'll create a subdirectory called wrapper, which will contain this class. So let's go ahead and copy the name. We'll create a new class under the newly created directory. and then we'll paste the contents of the file. Now, one of the things you'll notice if we try to deploy is that we have this unexpected token for the numbers. And this is because in Apex, we can't have numbers start at. That's why, for instance, if you make a field with a number, it normally starts with the letter X. And so we could parse this, but to be honest, we don't need it. So let's just go ahead and remove all the avatar information. Then we can go back to the test class and do the same thing where we create the test class under the wrapper directory, and we go ahead and copy that content file into the new class. And obviously we'll want to deploy this as well. Now let's go ahead and set up the callout inside our Jira callout class. So we can create a new method called getUser. And the getUser object will want one parameter, which will be the email. And that's because we're going to go and set up the whole query to just take in the email address. So let's make a public method that returns the HTTP response called getUser. And we'll take in a parameter of the email address. So what we'll want to do is we'll want to return the HTTP helper method where the endpoint is user/search. And then we'll add a query parameter of query. And the value of this parameter is going to be the email address. We'll have a method of get, and the body will be null. So let's go ahead and deploy this to Salesforce so that then we can ensure everything compiles. And now let's go ahead and create a class that's going to go and contain all the code needed to get a user. We'll call this Jira User Helper, and we'll put it in the new user directory. We can go ahead and rip out the constructor method, and we can go and create a new method that returns a user called getJiraUser, where we pass in a user object. And so we'll instantiate the HTTP response as callout.getUser, and we'll go ahead and pass in the user's email as the parameter. In this case, a successful response is 200. So if the response.getStatusCode does not equal 200, then we want to throw a new callout exception. Now, the way that this callout works is it returns an array of users. So the best way of doing this is instantiating a list of the user JSON. And then we want to go and use the Jira user.json.parse method where we pass in the response.getBody. So one of the things we need to do is we need to plan for a rainy day. And so what could happen is that the user JSON is parsed successfully, but doesn't return any records. So what we'll say is if the user.json.size is equal to 0, then we're going to throw a new Jira exception because, well, we didn't find the user. And so now we can go and assign the Jira user ID as the user JSON's 0th index.id. And this is a safe call because we already checked to confirm that the size is greater than 0. And then we can go ahead and return the user. So we can deploy this, and now we have our Jira user helper, and what we want to do is add this into a controller. So let's create a new class, call it Jira user controller, put it in the user directory. And once again, I'm going to use my snippet to create boilerplate, and we'll go ahead and update a few values. We'll change the ID to user ID. The record is going to be a user and not an account. Likewise, we'll change the name of the variable to you, and we'll change the action to create user. From here, we want to grab whatever fields we need. So we'll need the email and we'll need the Jira user ID. So to run this code, what we're going to do is we're going to use the Jira user helper.getUser. We pass in the user that we just got, and we want to update the user record if the callout is successful. So we can go ahead and deploy this. And let's go ahead and create a new visualforce to contain this controller extension. So we'll call this Jira user VF. And we'll do the same thing as before. So we'll delete the default values. We'll go ahead and add the standard controller. This time the controller will be user. And we'll add the extension as the controller we just created. And the action will be the action we just created as well. So let's go ahead and deploy this. Back inside of Salesforce, we can go and create a custom link. Now, I did find this to be the best solution for the user because the user page is a little weird. So we can create new button or link. We can call this Get Jira ID. We want to ensure we're executing a visualforce page, and we want this to display in the current window. Then what we can do is we can go to the page layout, go to custom links, and we can go ahead and drag the link as well as the field to our page layout. And so if we go to the user inside of Salesforce, click on the desired user, we can scroll down to the custom links section and we can press get Jira ID. Now, the way this controller works redirects us to the page that a standard user would see. So we'll have to go back to setup, navigate back to the user record, and we'll see the user ID populated successfully. And so this concludes our section on generating the user ID. So what we want to do is go back into VS Code and write some test classes. Create a class called Jira User Test, and we'll put this in the user directory. Once again, I have a snippet for mock callouts. Because we are using HTTP callouts and we want to simulate these, we will need the mock interface. As a design note, I prefer to have the mock classes inside my test class, and this way I can control the endpoints at a per test class basis. So let's go ahead, and if the endpoint contains user, then we want to return a response. And the other thing that I like to do is, because JSON to Apex gives us a nice JSON string formatted, what I like to do is move this string into a public string that any method can use. And then we can deploy this, and what we can do is set the body as the test class.json. And that way we're getting the same JSON response that we get from our JSON class. Down below, we can go and update the name to test controller. You can already see we set the mock as the HTTP call mock.class and the class we went and created here. Now, unfortunately, we are needing the user to test this, which makes it a little bit more complicated for tests. And so the way we need to do this is we need to get a profile. I'm going to get the standard user profile, which will always exist in a org. And then here is a sample user that gets created with various information. The key thing to look here is the username. This does need to be unique even within test classes, so make sure that you change this username. Then we also need to insert this because we'll need to use this inside our methods. Now we need to instantiate our standard controller, and this is done by using the apex pages.standard controller, where we pass in the user record. Then we make a new controller of our controller extension, where we pass in the standard controller as the parameter. And finally, we can go and inside a test block, we can run the action to execute our code. And what I would like to do is confirm that this controller ran successfully. So we're going to query the database, and we will assert that the Jira user ID was set. So let's go ahead and deploy this and run to confirm that our test code is good to go. And it looks like our test class here failed. And the reason why is because we have a duplicate value. And so even though we have all data equals false on the controller, we need to set the data from our JSON as a different value. The reason why this is happening is because we're actually inserting a user, and so Salesforce is checking the user ID even though we have all data equals false. To remedy this, let's go back to our JSON class, so Jira user JSON.test, and we'll change this ID from a real ID to some sort of fake ID. Now let's go ahead and deploy this class, and we can go back to the test class and run our code again. And now you can see that our test controller works great and we have some test coverage. Now that the test code has been completed and we have everything we need to create a project, let's go ahead and clean up a few things so that then we can get ready to create a whole wizard with Lightning Web Components. And that next part would be unhard coding all of our Jira user JSON values. So we already have a reference to the project lead, so we can go and reference the project lead and the Jira user ID from the project lead using the -r relationship. And what we want to do is, if there is no project lead, then we want to throw a new exception that says add a project lead. And then we can go and pass in the value of the account project lead and then the Jira user ID. Looks like I copied an extra field, so let's go ahead and remove the duplicate Jira project name field that I created.
So now this code will work when we deploy it for any Jira user that is synced. One final thing we want to do before we create the Lightning Web Component is we want to get a project from Jira. And we're going to use this method to ensure that the key we supply in the Jira wizard is not used. You can see in the documentation, what we do is we do a get callout to the project/key, and then the response is a 200. And here is a sample callout inside of Postman. Inside VS Code, let's go ahead and create a new method. So we're going to call this get project, and this will take in the key, and this will be a get callout. The body will be null, and the endpoint will be / and then the key appended. Let's go ahead and update the documentation as well. So we're going to take in a key as the parameter, which will be the project key that we are searching Jira for. So let's go ahead and deploy this. Also, we're at a good stopping point here. So I'm going to go ahead and open up the terminal, and I'm going to commit this to Git. So we'll just add all the files in the repo, and then we'll just give an initial commit message. And then we can go and push to GitHub. And this is a great way of Salesforce development, right? Just always backing up your code when stuff is done. Now that we have all the prerequisites done, let's go and create a Lightning Web Component. So we're going to call this Jira Project Wizard. Keep in mind that Jira is lowercase, and that is required by Lightning Web Components. And then what we can do is we can just scaffold out the UI. So we're going to have an input. This is going to be type text. I'll give it a label of project key. What another Lightning input of type text. Give it a label of project name. And we want to be able to select the project lead. So we'll have a Lightning record picker, which will allow us to set records from a given type. So in this case, the type will be user. We use the object API name as the property, and we set the label as project lead. Since we'll be running this inside a quick action, I'm going to go and add the Lightning quick action HTML tag and wrap our whole component around this. And this will format it nicely for the Lightning quick action. And unfortunately, this does give a formatting error. So I'm just going to add this SLDS validator ignore to ignore the error. Finally, let's go and add a header of create Jira project, which will show up nicely inside the quick action. One final thing we need is a way of submitting. So we can add a div with the slot of footer, which will put the button below the component. And then we can add a Lightning button component inside this div of the variant brand with the label of create project. And the title will be create project. So now we can deploy this, but we still need to expose this to the targets. So let's go ahead and open the XML. We can set is exposed to true, and we can add these targets. So we'll need a target of Lightning record action and the config, and we'll need the target config for the record action of the action type screen action. And this will allow us to add this as a button. Inside of Salesforce, we can go to the account object and create a new action. And we can select the type as Lightning Web Component. And we will select our Jira Project Wizard, and we'll call this create project. Then we can go and add this to our page layout so we can use it. Go ahead and drag it from the mobile and Lightning actions to the correct section. Then when we navigate to the account page, we can see the new action there. And when we press create project, we can see the official UI. One other thing we'll want to do since we're doing Lightning Web Components is we'll want to go to the session settings, and we're going to want to disable the secure cache. This way we can quickly see the updates we made to our component. As of the time of recording, this is the best way of developing Lightning Web Components. Keep in mind it's recommended to have this setting only in a sandbox and not in production. But let's go ahead and connect these values from the input into JavaScript so we can use them and submit them to Apex. So one of the ways of doing this is having an onChange method. This will run every time the value of the input changes. And so we'll make a onChange function called handle key change. And one of the things that you'll notice for syntax is that for our standard HTML values that are just strings, we have double quotations. And for functions that will reference JavaScript, we need the bracket notation. And we'll eventually make a value called key, which we will want to display in the input, which is very useful for displaying default values. Inside the JavaScript file, let's go ahead and instantiate a key variable. And let's go ahead and make the handle key change function, which will take in the parameter of an event. And we'll take this.key is going to equal event.target.value. And let's go ahead and deploy this component. Now when we're inside of Salesforce and we go and reload our component, when we go and update the project key, then we'll see that this value changes. But we have no way of confirming that. So let's go ahead and add some debug really fast. So I'll just say console.log and then this.key. Now when we deploy this and go back to the Lightning Web Component, right click and open the developer console or go and use the F11 shortcut. And then now when we change the project key, you can see that every single time it runs, we have the value being logged. So no need to have all of this debug getting sent to the user, but time to go and hook up the other inputs. So for project name, we'll have another onChange function called handle name change. Remove the quotes, and then we can add a value called name. I'll also enable word wrap, which will make it easier to see here. So we can set a variable, we'll call it project name. I'll go back and update the input later. I think it's more descriptive. And we'll make the function called handle name change, and we'll take an event as a parameter. And we'll say this.projectName equals event.target.value. And this event that we're taking in as a parameter is a standard HTTP event. So we'll come back in here and update this value to project name. Now what we want to do is we want to add a filter for the Lightning record picker. And this is because we want only project leads to be people who have a Jira ID. So first of all, let's go ahead and add an onChange method for handle the lead change. We can call this method handle lead change. And we can go ahead and instantiate the project lead variable. And then we can go ahead and create the handle lead change function that will once again take in an event. And this time it will be this.projectLead is going to equal event.detail.recordID. So now we want to add the filter. So inside the Salesforce documentation, we can see that what we need to do is create an object called filter with a key called criteria, which is a list of objects where we go and have a field name. We have an operator like equals or not equals, and we have the value that gets set. So in this case, we would want it null. So let's go ahead and instantiate this. So I'm going to call this object filter, and we need criteria as an array. And we'll make this filter off of the field Jira user ID. We'll say that the operation is not equal and the value is going to be null, or in this case, empty string. So back inside the HTML file, we can go ahead and update the tag to include the filter as the filter we just created. Now, if we go and load into Salesforce, we can look at the project lead and see that the record appears as expected. But if we go into setup user, and then we go ahead and remove the Jira user ID, what we'll see is that when we go and search for the same record, there's no record that can be found. One other thing we want to add quickly is a max length of 10 for the project key. This is just a input validation for the length according to Jira documentation. Now we want to go and add the check Jira key functionality. So I'm going to go ahead and create a Lightning button with the variant of base. We'll call this check key, and the title will also be check key. And when we go and deploy this and open it in Salesforce, we can see that this is weirdly placed. So what I want to do is I want to add some padding to the left, which will move it inwards. Also, we can click this and see that everything works as expected. Let's also go ahead and add the onClick functionality, which means every time we click the button, then it will execute some JavaScript. So we'll have the onClick function of handle key check, and we'll add that margin as well. And now when we refresh the page, we can see that this is in, I believe, a better spot. Now we can hook up the JavaScript functionality. So let's go ahead and create the function handle key check. Additionally, we will want to add the async property, which will allow us to run this in the background and not hang up the UI. And what we want to do is we want to communicate with our function that we created earlier inside of Apex. And so what I like to do is I'm going to create a class called Jira Project Wizard Controller. And this is going to be the interface between our Lightning Web Component and our existing Apex code. So I'm going to go ahead and rip out the constructor method, and we're going to create a new method called public static boolean check Jira key available. And this will take in a parameter of key. And we'll want to annotate this as Aura enabled so that then we can go and use this inside of our Lightning Web Component. Additionally, let's go ahead and add some documentation. So we're going to take a param of key of the potential Jira key. So we'll return true if the key has not been taken. Then what I'm going to do is I'm going to create a boolean of available. We're going to set this default to false. And inside a try catch loop, we're going to go and get the project based on the key. And what we're going to do is we're going to look at the response code to determine if the key has been found. So according to the documentation, a 404 returns not found, a 200 is found, and 401 is unauthorized. So let's go ahead, and if the response code equals 401, we'll go ahead and create a new Jira exception saying unauthorized. Maybe the key gets rotated, who knows? And we will set available is equal to response.getStatusCode does not equal 200. So if the response code is found, then it's not available. And if the response code is anything else, then we can use this key. And so then let's go ahead and return available, and then we can deploy this code. Now inside the Lightning Web Component, we want to import this class. The syntax for this is we have the method name, in this case, check Jira key available. And then we go and say from and the path, which is at Salesforce / Apex / class name, in this case, Jira Project Wizard Controller, and then dot check Jira key available, which is the method name. So first we'll have a variable at the top called available, and we'll say this dot available equals await, where we await the response of this function, and we'll say check Jira key available. And the way that we interface between Apex and JavaScript is we pass in the object of values. So the param key is going to be set as this.key. And so when I go and open the Lightning Web Component and I type in a key like Acme and I press check key, then we're getting a response. But once again, we still can't see this. So let's go ahead and console.log this.available. Now when we go and refresh the page and open up the developer console, when we press check key, we can see that the Acme is not available. But when we go and have a key of ABCD, this is available. And this is great, but now we want some haptic feedback for the users. Let's go ahead and add some icons. We'll add a nice X if it's not available, and we'll add a checkbox if it's available. So inside the HTML, we can use the lightning icon to add these icons. We want the icon name of utility check for the available, and we'll just have alternate text as available. The title will be available as well, and the variant will be success. That will make this green. Similarly, we want another lightning icon for the X, and in this case, it will be utility close, and the alternate text will be not available, title will be not available, and the variant will be error, which will make this red. So now when we deploy this, we can actually see our icons. So let's go ahead and refresh, and we can see that we have a checkbox and an X. But what we want to do is we want to display these based on the value of available. So let's go ahead and use the template, which is a way of using front-end logic to display based on values in the JavaScript component. So we'll say LWC if available. Keep in mind we want to remove these string quotation marks. So if the icon's available, then we want to show the icon as available. And we'll add another template of LWC else, which will be the end scenario. Because it's an else statement, we don't need to check the condition, and so we'll throw the not available here. So now we can deploy this and check the component. And when we refresh, we see that the variable is not set. And so we have immediately an X, but let's go ahead and test this anyway. If we go and add a key of ABCD, then you can see the checkbox is displayed. And if we do Acme, then the X is displayed. So this is working as expected, but we need to set an initial value. And so what I want to do is create another variable called not checked key, which just is immediately set to true. And what we want to do is if there is a key checked, then we want to set this to false. And that way then we can use an additional template to display neither of them. So up at the top, we'll add another template that will be LWC if, and if it's not checked key, then the template is empty. And then else if available, then we show the available. Keep in mind that the template will only display the first one. So if it's true, then it'll display nothing, even if it's available, evaluates to true. So we have here Acme that shows nothing, then we check the key, and it shows an X, and then we show ABCD, and this is available. So with the handle project key check logic done, let's go ahead and actually create a project. So inside the Apex controller, we can add another or enabled method. We'll have a Boolean of return type, and we'll call this create project. And this will take in a string of key, a string of project name, an ID for the account ID, and the ID of the user from the record component. Then inside the try catch, we can go and call the Jira project helper .create or update project, and we'll pass in an account and the project lead ID. But we want to get these values, and the easiest way of doing that is actually in Apex. So what we can do is we can create a new account object, and we can assign the ID as the account ID. And this is a quick hack of getting the record without using a SQL query. And then we can go and set the Jira project key as the key we just had. And we can set the name as the name we passed as a parameter. And we can set the project lead as the user ID that we also got as a parameter. Now let's go ahead and get the user value, which will be important to get the Jira ID. So if we say user equals select ID, Jira user ID from user, where the ID equals the user ID, we can now have the Jira user ID as well. And we can just go ahead and, for simplicity's sake, say that project lead ID equals u.Jira user ID. And we'll have a Boolean of success, which we'll set as a default value of false. We'll go ahead and assume that after the update, we can set success is true because no error was thrown. And we can go ahead and return the success variable. So let's go ahead and deploy this. And once again, we want to import this. So let's go ahead and copy the original import for the function. And this time we'll change the function from the check Jira key available to create project. And we'll go ahead and deploy this. We'll also need a few additional values. And so what we can do is we can import API, and we can get reserved values based on the record we're on. So we can use the API decorator to get the record ID as well as the object name. And I'm not sure why the formatting isn't working for this, but that should be a different color. Let's go ahead and create a new function called handle project create. We'll once again have this async. As any callouts, it's generally best to have as async. So we'll have a try catch inside this. And for now, we'll just go ahead and console.error the message if there is an error. So what we'll do is we'll await create project, and we'll pass in an object of all the parameters. So we'll have the key equals this.key. The project name will be this.project name. Gotta love autocomplete here. We'll have the account ID is going to be the record ID. So this.record ID. And then the user ID is going to be this.project lead. So let's go ahead and deploy this. And one last thing we need to do is we actually need to hook this function up to our button. So let's go into the HTML and we'll add an onClick method for the function we just created. Finally, we can go and deploy this. And when we go and refresh our component, we can go and test everything. So we'll enter the ABCD as our project key. We'll enter some gibberish name, and we'll add our project lead there. And we'll go ahead and press create project. And we got an error. What is this error? So it looks like this error is due to some of the testing, and so you shouldn't face this, but because I deleted this in the past, it is marked as available, but isn't actually available. So we can quickly go and change the key and then press create project. And this error looks to be a bug in the code we wrote. So inside the controller method, we are passing in the ID of the user instead of the project lead ID. So let's go ahead and update that and try to create it again. And funny enough, because it's an Apex method, we don't need to refresh. So I'll go ahead and press create project. And when we open this up in Jira, we can see this project name created. And this is great, but we really don't want to have our whole wizard open after the project is created. So let's go ahead and add some screen events to go and tell the user what's going on. So first of all, we need to import a few things to control the navigation. So we'll import the show toast event and the close action event. What we can do is we can say this.dispatch event, and we can create a new close screen event action. And we can also dispatch a toast, which will take in the object as a parameter, and we'll say the title is success, and the message is Jira project, and the variant will be of type success. Also, we can go and instead of console.error, we can dispatch a toast to the user. So we'll replace this with the same code as before, but we'll have this as an error. We'll say could not create Jira project, and the variant will be error. So when we go and test some of this, we can first of all just create a project. We will know error, and that toast is working successfully. But let's go ahead and create a valid project. And when we go ahead and press create project, you can see that the toast works as expected and the action itself closes. Now let's go ahead and fix this ability to submit when all the data isn't populated, so we can go and actually disable the button. So what we'll do is create a variable called project creation disabled. We'll set the button's disabled state to the value of this variable. And after deploying and opening it, you can see that this is what a disabled button looks like, and there's no way of clicking this. So now we need to go and hook up the logic to make this function properly. So we'll create a new function called check project creation, which will go and assume whether or not this can be created. And so we'll say this.project creation disable equals not this.available, or this.project lead equals undefined, which means the project lead is not set, or this.not checked key. And so if any of these conditions are true, then we want to disable the button. And then what we can do is on some of our event handlers, we can add this function. So when the name change happens and the key change and the key checked, we can say this.check project creation, which will run the code we just created. And so now when we go and refresh inside of Salesforce, we can see this logic in action. So if we go and add a name, nothing happens. We add a key, also nothing happens. We add the project lead, still it's disabled, but once we check and it's available, then we can go ahead and create the project. So this is pretty good, but the one last thing is this is a creation wizard. So we actually don't want people to create a project if it's already been created. So if there's a project ID, then we want to just close this out. And so we can get data from records inside of Salesforce using the wire decorator. And so wire has a strange syntax, but what we can do is we can say @wire, and we can pass in the function getRecord. And this getRecord will take in the parameter of an object, which will be the record ID. And then we want to get the record ID using the $record ID. And additionally, we want the fields to be various fields, and we can import these above. So let's go ahead and actually import everything we need. We can go ahead and import the get record and the get field value methods from lightning/UI record API. And then we can import individual fields like project E from @salesforce/schema/object name, in this case account, .jira project key, aka the field name. And then we can do this for a few other fields. So we'll want the name and the ID, and we can go ahead and update the names in the import path as well. So inside of fields, we can add the fields we just imported. Keep in mind it's considered best practice to have all of these be uppercase values. We can also create an account variable to get this information later on. And now the next part of the wire syntax is all of this is actually just parameters inside the wire decorator. So we'll want to create a function called wired account, which will take in an error and a data parameter. And this is not always having data. And so we always want to check if there's data, then we do stuff. Also, if there's error, we do stuff. And both of these could be null. So that's why we have to check like this. Let's go ahead and console.error the error, and then we can go ahead and
if there's data, we can say this.account equals data. We can also check the field values. So if the get field value of the data, and we can check with the project ID, then what we want to do is say this.dispatch event, and we'll dispatch a new close screen event. We'll dispatch a new toast where the title is error, the message is Jira project already created, and the variant is error.
So now we can go ahead and run this one last time, and we can see that the screen closes automatically and we get that toast. And let's go ahead and commit this now that we're done with the Wizard components. So a couple things that can be improved would be getting the values from the account if some of these field values have already been set, as well as converting this to a record edit form, which we'll be using later on. Now let's go ahead and put an end cap on the project stuff. So we're gonna go ahead and create a new class called Jira Project Test. That way we have full test coverage of what we did. Once again, I'm gonna use my snippet to have some boilerplate. And I'm gonna go into the wrapper file for the Jira project and move that JSON from the body of the initial method into the class variable so that then we can access it inside our test class. Then we can go and update our endpoint to be project. And we'll set the body to Jira project JSON underscore test.json. And we'll set the status code as 201. And what we're going to do is we're going to copy this for additional endpoints. So if the endpoint contains project and a slash, then we want to send the same body, but we want to have a status code of 200.
We also need data for our test methods. And so what we can do is we can have a test setup method called makeData. So once again, we'll query the standard user profile. We'll create a demo user, insert it, and then we can create a test account with the project lead set as the user we just created.
And so inside our test method here, we have, of course, the set mock. We can give this a nice name like test controller. This will be for the original visualforce controller. So what we need first is an account. So what we can do is we can query the account created in the makeData setup method. Then we can go and create a new instance of a standard controller using the Apex pages.standardController class, where we pass in the account as the parameter for the constructor method. Then we can go ahead and create a new instance of the Jira project controller where our parameter is the parameter for the construction method is, of course, the standard controller. Then we can start our test loop with test.startTest. We can run the action using controller.createProject, and then we can stop the test here. Now let's go and check the data. So we can look at the account after update, and we can query this data from the database using a SOQL query. So we'll select the ID and the Jira project ID from account, where the ID is the original account ID's ID. And we want to assert that the Jira project ID is not blank. And once again, it's best practice to add a message after your assert in case your test methods are failing. So we can deploy this and we can run this to confirm that this works as expected. And we are getting an error here because the Jira project ID was never set. So it's a good thing we ran this test class. Let's go back and check if our JSON had an ID, and it looks like it didn't. So I'm going to go ahead and copy one of the properties and change it to ID, and we'll just add some random ID. This will never collide with any real record IDs. Now we'll go ahead and run our test and we get a success. So very good. Next, let's go ahead and add some test classes for our methods from the Lightning project wizard. So we'll create a new method annotated as isTest. This will be a method called test check key. And we want to set the mock like we did previously so that then we can make third-party callouts. And because we don't need any record data, let's just go ahead and start the test where we have available equal to our Jira project wizard controller .check Jira key available, where we pass in just a random key. And keep in mind, since this is a mock, all we're looking at is the status code. So what we'll do is we will system.assert that the key is not available, which is our expected behavior. So let's go ahead and run our test to confirm that our code works as expected. And we once again have a successful test. So finally, let's go ahead and commit this. Now we have test classes written, so we'll add all of the classes and we will commit our test classes accordingly. Switching gears here, I want to talk about the project architecture for the opportunities. So every account can have multiple opportunities, right? This is quite standard Salesforce. So we can model this here with one opportunity, and we can obviously have, like I said, multiple opportunities. And additionally, each Jira project can have multiple versions. And really what we want is we want a connection from every opportunity to every version. So each opportunity will be linked and have a one-to-one relationship with every version. And just so I can show you what we're integrating in the UI, because it's a little confusing, there's a tab called Releases where we press a button called Create Version, which will create sometimes is called a new fix version. All of these are interchangeably the same things, which I will be using most likely all three terms. And you can see here we have a fix version field on the Create Issue page. Inside the Jira documentation, we can see that we have a create version, which is a post request to the version endpoint. And really, there's only a few things we need. We need a project name, we need a project ID, and that's really the only thing we need. We can also add a description. So inside of Postman, let's go ahead and replicate this. And we can see that we successfully created a version for this project. Inside of Salesforce, let's go to the opportunity and create the fields required. So we're going to go ahead and create quite a few fields actually. So let's go ahead and first create the field Jira fix version name. And this is because we can have an opportunity name that might be different than the version name we want to put inside of Jira. Next, we'll create a formula, which will be called Jira project ID. And this will just be a lookup to the account's project ID, which will just save some SQL queries and headache down the line to have this formula. Next, we'll create a text field called Jira version ID. This will be an external ID and it will be unique. And with all the fields out of the way, it's time to create the wrapper. So back to the documentation, let's go ahead and copy this JSON. We'll paste it into JSON.apex. We'll call it Jira version JSON, and we'll go ahead and download and save to our project. I'll go ahead and unzip this as well. And once again, we want to create a version folder. So we'll create exactly that folder called version. And inside that folder, we'll have a wrapper folder so that then when we go and create the Jira version JSON class, we can put it in the new wrapper folder under version. And let's go ahead and copy this to the class and deploy it to Salesforce. And additionally, we'll add the test class. So let's create the test class with the Jira version JSON underscore test name, copy the code, and deploy this to Salesforce. Next, we want to go and add the endpoint that we'll be using. So I'll go ahead and create a new method called create version. So once again, we want to return a HTTP response. We'll call this create version, and the parameter will take in a string of the version data. We'll go ahead and return the HTTP helper to the version endpoint. This will be a post method, and the body will be our version data. And we can add some java.comments as well, where we specify that the param version is the version data we send to Jira. So we'll go ahead and deploy this. And let's go ahead and create a new class called Jira version helper, which will contain, once again, all of the methods to create a version. We'll go ahead and create a new method called create version, which will return an opportunity, and we'll take an opportunity as a parameter. We'll say the Jira version JSON version equals null for now, because we actually want to create another class that maps to this. But to finish the rest of this class, we want to instantiate a new response object, which will be created with the Jira callout.createVersion, where we serialize the version JSON we are going to map. Then we'll go and look at the response code. So if the status code does not equal 201, which is a successful version creation, then we'll throw a Jira exception, which says we could not create version. Then what we want to do is we want to parse the response. So we'll create a new Jira version JSON called version response, where we parse the response.getBody. Then at some point we'll want to map the version to the opportunity, and let's also go ahead and return the opportunity. Now we can deploy and everything works as expected. So let's go back and create the mapping file. So we'll create a new class called Jira version mapping, and we'll put it in the version directory, throw out the constructor class, and we'll create a new method where we return the Jira version JSON, and we'll call this map opportunity to version, where we take in the opportunity as a parameter. We'll instantiate a new Jira version JSON called version. We'll start assigning class variables. So the name is going to be the opportunity.jirafixversion name. Next, we'll have the version ID be the version ID. We'll have the description be the opportunity name, and we'll have the project ID be the integer. Keep in mind, we had an integer for the project ID for this. So we'll parse the integer of the project ID. Then we can go ahead and return the version. One last thing I'd like to do is just do a check, because if there's no project ID, then we can't create a version. So what we'll do is, if the project ID is blank inside this formula that looks at the accounts project ID, then we'll go ahead and throw a new Jira exception. And we'll give it a nice error like cannot create a version with the Jira project ID null. So let's go ahead and deploy this. And it looks like the ID was not put in our initial JSON, so we'll create a new string ID as a class variable. Now when we deploy the version JSON as well as the mapping, we can use this. Inside the helper class, we can use the Jira version mapping.map opportunity to version, where we can create this. So let's go ahead and deploy this. And it looks like I forgot to deploy the mapping class, so let's go ahead and deploy this. Go back to the helper class and deploy that. Back inside the mapping class, what we can do is we can add a new method. So we'll return an opportunity, and we'll call this map version to opportunity. And this will take in the parameter of the Jira version JSON as well as our opportunity. And what we want to have is we want to have the Jira version ID be the string value of the version.id. And we'll go ahead and return the opportunity. Now we can update the mapping. So we'll remove the comment and say the Jira version mapping.map version to opportunity, where we pass in the version response JSON, format this, and save, as well as deploy. With the general methods out of the way, it's time to create a Lightning Web Component. So we can create a Lightning Web Component called Jira version Wizard. Keep in mind, once again, the first letter is lowercase. And we can once again start by scaffolding the UI. So this time we're going to use a record edit form. So this works by setting the object API name, which we'll pass in as the object API name, as well as we need a record ID, which we'll get from the API. Now we can go and add an input to edit a field value. So this uses a Lightning input field as a tag, and it takes in a field name, which we'll just have it set as a name field. From here, once again, let's wrap this in the Lightning quick action panel.
And then we want a header of create Jira project. Wrap the whole entire record form around this. And once again, we'll add this SLDS validator ignore. We'll go ahead and deploy this.
Now let's go ahead and get this set up to put in an action. So we'll change is exposed to true. We'll add the targets of the Lightning record action, as well as the target config to be the screen action. Before we go and deploy this, let's actually get the whole record form set up. So we need to import the API from Lightning Web Component, and then we can get the record ID as well as the object API name. So we'll also want to import that name field. So let's create a variable called name field, which will be called version name. And that version name is going to be a reference to an imported field. So we'll import that field as the version name from Salesforce/schema/opportunity.Jira fix version name. Now let's go ahead and deploy this so that then we can get the whole Lightning Web Component set up. Inside of Salesforce, we can go to buttons, links, and actions, create a new action, change this to Lightning Web Component, select our Jira version wizard, give it a name like create Jira version. We'll go ahead and save this and add it to our page layout. So we can go to our opportunity layout, go to mobile and Lightning actions, drag it to the section and save. And when we navigate back to an opportunity record, so I'm going to go ahead and create one really quickly, just give it some default values. We can run the record and see we have an ability to see the value of the field. And if we actually go and change the value of this field, so we'll call this test version 123, you can see that when we run the action, we actually have that value populated automatically, which is the power of using that record edit form. Back inside VS Code, let's go and add a button so then we can submit values. So I'm going to add a div with the following class, and this will give a little bit of padding on the top so that then the button isn't so close to the field. And then we want to add a Lightning button element. This will be a variant brand, type submit, and we can add the onClick method here, which we'll call handle version create. And we'll add a button label of create version. Let's go ahead and deploy. And when we go back into Salesforce, you can see that the button appears as expected. But even though I'm clicking on this, we don't have anything set up on our onClicks. So let's go and wire that up. We'll create an async method called handle version create. We'll wrap this in a try catch block. Now we need the ability to interact with our Apex code. So let's go and create a new class. We'll call it Jira version controller. Put it in our version directory. We can remove the constructor code and we can add an Aura enable method. We'll change the return type to void and we'll call this create version. We just want to pass in the ID of the opportunity and we'll actually just get the opportunity details inside here, which we can do by setting the opportunity as a SOQL query. So we'll say select the ID name, Jira fix version name, Jira project ID, and the Jira version ID from opportunity where the ID equals the op ID. Now we can go and use the Jira version helper.create version where we pass in the opportunity we just got from the database. And of course, we want to go ahead and update the opportunity. Now let's deploy this, and back inside our Lightning Web Component, we can import this method. So we're going to import the create version from the Salesforce Apex Jira version controller.create version. Now let's go ahead and await the create version, and we can pass in the opportunity ID as this.record ID for our parameters. As well, let's go ahead and import the close action screen event as well as the show toast event. So what we'll do is we will dispatch the close action screen event, and we'll write this as a success. And if we do manage to catch an error, then we will show the error. So let's go and test this out. Let's go to our web component, create a version. We can see that we have a success. And if we go inside of Jira, we can see that version just got created. To wrap up the version creation, let's go and add some test classes. So we'll make a new class called Jira version test, put it in the version directory. I'm going to once again use my test mock snippet. We'll want to change the endpoint to ends with version. And inside the Jira version JSON test class, we can go and move this JSON from the test parse method to a public class variable. Go ahead and deploy this. And back inside the test class, we can set the status code as 201, which is a successful response. And then we can set the body as the Jira version JSON underscore test.json. Scrolling down, we can add some test setup data. So I'm just going to quickly paste in a method called makeData, which does the user creation like we had previously. We also create an account. As well, we create an opportunity with the necessary data. From here, let's go ahead and rename this method to test controller. We'll go ahead and retrieve the opportunity we created in the test data by using a SQL query where we filter based on the name. And we'll start a test block, and inside that test block, we'll go ahead and run our controller.createVersion, and we'll pass in the opportunity.id. We'll end the test block, and we will once again retrieve the opportunity from the database to ensure that the version ID was written. So we'll say opportunity op after equals select ID Jira version ID from opportunity, where the ID equals the opportunity ID. And we will system.assert that the ID was set using the string.isNotBlank. Additionally, it's good to always throw some sort of descriptive message if your test class assertion fails. Let's go ahead and deploy this to Salesforce, and then we can go and run this to confirm that our controller works as expected. And we do have a failure here. It looks like the version ID was not set. So let's take a look at why that happened. Inside the mapping document, let's take a look here, and the version ID is being set. First, let's confirm that the JSON has an ID value, which it looks like it doesn't. So we'll quickly add that ID value here. And this also needs to be a string. So we'll add quotations as well. We can go ahead and deploy this and run our test again. So we can run the test again, and we can see here that we once again get a failure. And we're getting the same error, and it looks like that's because in our helper class, we were not using the version response. So we'll go ahead and update that method to use the version response and run the test class one last time. And we have a working test class. So finally, let's go ahead and put a cap on this by committing the code. We'll give a nice commit message like version code, and we'll go ahead and push this to GitHub. The last thing we want to do is we want to integrate the issues from Jira as cases into Salesforce. And so we can use this search for issues using JQL endpoint, which JQL is a way of querying Jira. It's basically the Jira equivalent of SQL. And you can read more about the general structure here of how you configure a JQL query. But the easiest way to get a JQL query is just set some values inside the issue search tab. And then on the side, we can switch from basic to JQL, which will get us our JQL that we can pass as our issue query. So inside of Postman, let's go ahead and run a sample query, and you can see that we get that issue data. And this is quite a lot of data. You can see as we scroll down, there's custom fields and additional data and fixed versions. And so we will want to parse all of this. The custom fields will be based on your Jira configuration. So let's go ahead and make a JSON wrapper. So we're going to go ahead and copy this method and go to JSON to Apex, paste that in, and we will call this Jira issue query JSON. go ahead and download the code to our project. And we can go and unzip this using the UZ method in the terminal. And you can see as we scroll down, we have quite a few subclasses that get parsed out. Let's go ahead and create a new folder for our issues endpoint, and we'll create a subfolder for the wrapper. Then we can go ahead and create a new class called Jira Issue Query. We can paste that data from our class, and we can try to deploy this, but we already see we will need to clean a few things up. First is the avatar URLs once again. The other thing that you'll see as we scroll up the class is a lot of things have the type of object. Now, this is not a bug from JSON to Apex, but it's not really a supported type. And so what we want to do is we want to remove the avatar URLs subclass that we just created, as well as any reference to object. So you can see when we deploy, it does compile correctly, but you will get a runtime error if a value is written to these object values. So we can quickly do this by searching for object and just deleting all of the lines. And we can just add the accompanying test classes. So we'll create a new class called Jira Issue Query JSON underscore test, and we'll copy that test class data from the downloaded class into the class inside our project. Go ahead and deploy it. Finally, I want to talk about the architecture for the issue sync. Suppose we have an issue inside of Jira. This issue can be related to a case as a one-to-one relationship. Now, each case we want to be able to relate to an account or a project, as well as an opportunity or a version. So to set up this data model inside of Salesforce, let's go to the case object, and we can create a new field of type text. We'll call this Jira Issue ID. Make sure it's an external ID and unique. We'll create another field. This will be another text field. We'll call this Jira Key. Once again, make sure it's an external ID and it's unique, as this will be the issue key, for instance, Jira-1. We'll create another field of type text. This will be called Jira Project ID, and we'll store the actual project ID on the case, which will allow us to link back to the account. We'll create another text field. We'll call this Jira Version ID, which will store the version ID, which will link back to the opportunity. And finally, we'll create one more field of a lookup relationship, which will be to the opportunity. And we don't need to create a lookup to the account because that is a standard relationship for the case. One last field, we can create a number. This will be the time spent in seconds. And we also want to convert this number to hours. So we'll create a formula called hours worked. And this will be the number of seconds divided by 60 twice. So there's 60 seconds in a minute, and there are 60 minutes in an hour. One final thing is that we will be mapping to the standard field called status. So we'll move our issue status to the case status. And so I would recommend going and updating these values inside of status to include whatever your Jira process has. So for instance, to do in progress done should be added to the status field in Salesforce. Back inside of VS Code, we can go and update the Jira callout class. We can add a new public method that returns an HTTP response called getIssues. And our parameter here is going to actually be a map of string, and we can call this params. And the reason why we want to do this is because the endpoint search takes in a list of URL parameters. And so what we can do is we can actually dynamically give URL parameters based on the map of parameter to value. And so what we can do is we can actually iterate through the key set with a for loop, and we can just append the key, which will be the key, an equal sign, and the value of the key at the map. And we can also add an ampersand at the end to concatenate params. Then we can go and return the HTTP helper where we have an endpoint, we have get as the method, and the body is null. We can go and add some documentation. So we'll say the param of parameters is the Jira issue search query parameters. And we want to update this to params, not parameters. Now we can go ahead and deploy this. And the next thing we want to do is we want to create a class. So we'll call this Jira issue helper, put it in the issue directory. And this time we'll actually code this in a more object-oriented style. So I want to initialize the Jira issue helper class with the map of the parameters. And we want to set this.params equals params, and we'll go ahead and add some class variables. So first, let's add a list of cases. And we also want to add an integer called total count, which we can get and set. And then we want a map of string called params, which we initialize inside the constructor method. Now these other two class variables will make sense shortly, but let's go ahead and scroll down and create a new method that's not statically typed called getIssues. And what we want to do is we want to instantiate an HTTP response object that is the Jira callout.getIssues. And we just want to pass in the params. And we want to say if the status code does not equal 200, then we throw an error. And then what we'll do is we'll say the Jira issue query JSON of query is going to equal the Jira issue query JSON.parse method, and that will take in the response.getBody. We want to map our cases to null for now, but we'll add a mapping class shortly. And we also want to set the total count equal to the query.total. And we'll use that later on when we're looping through all of the cases. Now let's go ahead and deploy this to Salesforce. You can see that everything compiles successfully. And so it's time to create a new class. So let's create that Jira issue mapping class, put it in the issue directory. And here we'll go and remove the constructor method. We'll create a new method that returns a list of cases called map issues to cases, which will take in a parameter of the Jira issue query JSON. First, we'll instantiate a list of cases as a new list. Then what we'll do is we'll say for each issue, which is a subclass of the Jira issue query JSON. So for each issue in the query.issues, we want to do a few things. So we want to first create a new case. Then we want to go and assign all the values. So the Jira issue ID is going to equal issue.id. We want the subject, which is kind of like the name, to be issue.fields.summary. We want the Jira key to be issue.key. We want the case status to be issue.fields.status.name. We want the case time spent to equal issue.fields.aggregate time spent. And that's enough mapping for now. Let's go ahead and add this case to our initial list of cases. And then we can go ahead and return the list of cases. So let's go ahead and deploy this, and we can see that aggregate time spent wasn't in our initial JSON. So what I'm going to do is I'm going to go and create this field inside the JSON class. So we'll say public integer aggregate time spent inside that field subclass. And so now we can deploy both of these classes, and everything compiles and is created correctly. So now let's go ahead and make a new class. We want to create a new class called Jira issue Queueable. Once again, put it in the issue directory. And I have a snippet that will put the baseline things that we need. Let's go and remove some of the stuff we don't need as well. So critically, this class will implement Queueable as well as the database.allowCallouts interface. So let's start by changing this constructor method. So we'll want an integer of current count, an integer of total count, an integer of batch size, and an integer of stack depth. We can then go and assign the class variables as the parameters from the constructor method. So current count, total count, and batch size, and stack depth. Let's also go ahead and create these class variables. And then what we're going to do is inside our execute method, we're going to initiate a new map of string called params. And we can add parameters based on a few various entry criteria. So the first thing is that if the current count does not equal null, then we want to go and add some sort of start at so that then we can iterate through a large list of issues. So we'll put the start at and then the string.value of current count. We'll also say if the batch size equals 0 or it's null, then we'll have this infinite loop. So let's just go ahead and throw a new Jira exception that says naughty naughty. And we put a null check like this in place so we don't shoot ourselves in the foot later on. Then let's go and always add the parameter max results, and that's going to be the string.value of the batch size. And so this is set in place so that then we can choose how many issues we query through. Then let's go ahead and instantiate the Jira issue helper. So we'll say Jira issue helper issues equals new Jira issue helper and pass in that params we just created. And we'll say issues.getIssues, which will retrieve the issues. At some point, we'll want to go and add an update method to update the cases. And to continue iterating, what we want to do is say this.currentCount plus equals the batch size. And then we want the total count to equal the issues.totalCount. Then let's go ahead and iterate through this. So we can say if the current count is less than the total count, then we want to create a new queueable. So we can use the system.enqueueJob and create a new instance of this Jira issue queueable, and we'll pass in all the parameters. So this.currentCount, this.totalCount, this.batch size, and this.stackDepth++. Now let's go ahead and deploy this. And you can see that this was created successfully. So back inside the issue helper class, we can go and create a new method to update the cases. So we'll add a new method called update cases. And what we can do is we can use the database.upsert result, instantiate this as a new list of objects, and we'll say database.upsert cases. And we want to specify the external ID, in this case is Jira issue ID. And then we want all or nothing to be set as false. And then because we're actually getting the upsert results, what we can do is iterate through these and debug the result if it's not successful. So say for upsert result, if the result is not a success, we want to system.debug the result.getErrors. And this is a good way of checking to see if there's any errors against the database. So let's go ahead and deploy this. And let's go ahead and hook up that update method to our queueable, and we can deploy this. And now what we can do is we can actually use this queueable inside another script. So let's go ahead and create a new script. We'll call it issueQueueable.apex. And instead of these class variables, we can change these to the appropriate values. So stack size 0, I want a batch size of 50, total count is 0, and the current count is 0. Now in my case, I want some issues a little bit further on, so I'll have a current count of 1200. And what we can do is we can go ahead and run this, and you can see that the queueable was enqueued successfully, but we don't actually get any debug logs from this. So what we can do is inside of VS Code, we can turn on the Apex debug log. And this is similar to how the developer console debugs logs. And once this is on, let's go ahead and execute this again. And then we can go ahead and get the debug logs to see what's going on. It says attempted to upsert a null list. So let's go ahead and debug this. If we go back to our helper class, we can see that our cases is null. So let's go and change our cases to the Jira issue mapping.map issues to cases. Go back to our script and execute this again, and we get a success. So now inside the case, we have a sample case, which works well. One thing that would be nice is we would like the datetime open to match, but this datetime opened is a Salesforce formula, so it's not possible, but all the other fields are mapped as expected. Now we did want to link the account and opportunity, so let's get that code set up. What we want to do first is set the Jira project ID to the issue field's project ID. And what we'll do is we'll check the fixed version size is greater than 0. And then if it is greater than 0, then what we'll do is we'll say the Jira version ID equals the issues.fields.fixedversions 0th index.id. And so this is good for getting the actual IDs on the case, but we also want to link them to the actual records. So the fail-proof way of doing this is querying the records from Salesforce. So what I'm going to do is I'm actually going to add 2 sets of strings for the project IDs and the version IDs. And then we'll go and add the project ID and the version ID to the respective sets. Keep in mind that a set basically dedupes the strings, so it's possible to have multiple project IDs as well as multiple version IDs. And then we want to have this run in O of n time. So the best way of doing this is creating a map of string account to the account map. And because, to be honest, we're only going to be looking at the ID, we can change this to a map of string ID. One of the things I like to do when working with maps is set what the ideal key is in the documentation. That way then later on I don't need to remember and look through the code. So the key will be the Jira project ID and the value will be the account ID. And we'll instantiate a similar map called an op map of type string ID, and this will be for the opportunities. And we'll say here the key is the Jira version ID and the value is the opportunity ID. So this is the considered best practice way of doing any record lookups in O of n time. So what we'll do is we'll get the list of accounts. We need the ID and the Jira project ID from account, where the ID is in the project IDs. We'll loop through the list of accounts. So we'll say for account and accounts, and we will put the Jira project ID and the account ID in the map. And we'll do the same thing for the opportunities. So we'll create a new list of opportunity called ops. We'll select the ID and the Jira fixed version ID from opportunity, where the ID is in version IDs. We'll loop through these opportunities. So we'll say for opportunity in ops. We want to put the opportunity.Jira version ID and the opportunity.ID in the map. Now, finally, we want to loop back through the original list of cases. So we'll say for case C in cases. And what we'll do is we will check if the account map contains the key project ID. Then we'll go and set the account ID as the account map.getProjectID. And we'll do the same thing for the opportunity. So if the opportunity map contains key the Jira version ID, then we'll set our custom field opportunity to the value of the opportunity map for the key that is associated with the Jira version ID. And let's go ahead and deploy this. We do have an error. Should be issue, not issues. One other thing we should change is instead of the ID, it should be the Jira project ID for the accounts, and for the opportunity, it should be the Jira version ID. So we can go ahead and deploy this. And here I have a sample execute anonymous for this individual issue. And we go and look inside the issue on the Salesforce UI, you can see we have the account and opportunity linked. And so this Queueable is working as expected. And so it's time to go and set up some sort of nightly batch sync now that our one-time sync is working. And so inside of Jira, you can see that we have a JQL with the created date. And I'll show this as well inside Postman here, where we can query data based on the created date. So let's go ahead and create a class. I'm going to call this Jira issue batch and put it in the issue directory. Let's go ahead and set this batch class up. So we want the Jira issue batch to implement a few interfaces. First of all, the database.batchable, S-object, database.allows callouts, schedulable. Now we need to implement the methods. So first we'll implement the execute method with a parameter of schedulable context, SC. And this is the method that we need to implement for the schedulable interface. And so what we'll do is we'll say the Jira issue batch equals new Jira issue batch. And we will database.execute batch and this batch class. Then we'll implement the next method. So we want to return the database.queryLocator, and the method name will be start. And this will take in a parameter of batchable context BC. And here we'll return the database.getQueryLocator and an actual query. So in this case, I'm going to select ID from account limit 1. And this is just some sort of hack to basically schedule classes that call out to third-party systems. Next, we want to implement the execute method for the batch class. So this is a method called execute, and it takes in a parameter of batchable context and the list of the S-object type, in this case account. And in this, we want to go ahead and get cases eventually, but finally, let's go and implement the last method we need, which is the finish method. And so this finish method takes in batchable context BC, and we'll just debug that the method is finished. So let's go ahead and deploy this to confirm that everything compiles. And now we can get working on implementing the nightly sync. So let's go ahead and create a new map of string called params. And what we want to do is we want to have a string of our JQL, which is how we're going to get the updated values. We want to update this JQL to be the actual query we want to run. We can add a little bit of documentation that says what this JQL does. Well, this will get issues updated in the last day. We'll change created to updated. Then what we want to do is we want to put in the params JQL the URL encoded JQL query. So we can use encoding.util.url encode, pass in the JQL string, and the encoding format, which is UTF-8. And this is because we need to have JQL in the query and we can't have spaces in the URL. A little confusing because Postman does this automatically. Next, let's go ahead and add a max results of 100. And then we can instantiate the issue class. So the Jira issue helper issues equals new Jira issue helper, where we pass in the parameters. We want to go ahead and get the issues, and we want to update the cases. And so now when we deploy this and run this, we now have a way of getting issues updated in the last day, which is very useful. And to run this, we can just go ahead and highlight this batch class, and we can execute anonymous with the currently selected test. So finally, let's go ahead and wrap everything up with some test classes. So I'm going to create a new class called Jira issue test and put it in the issue directory. Once again, I'm going to use my mock snippet. We'll say that the endpoint contains search. We'll go ahead and update the issue query JSON, and we'll move the JSON outside the test parse method into the class variable and assign this as public. Go ahead and deploy this so we can use it in our test class. And back inside our test class, we can go and update the body. First, let's go ahead and add some setup data. So we'll create a test setup method called makeData, which will just add the various details we need. Then inside our method test batch, we can go and test the batch class. So we'll instantiate the new batch class, call it batchable. We'll have a test.startTest equals database.execute batch and the batchable, and we'll stop the test loop. And we can assert that the batchable does not equal null. This is a great way of, I would just say, faking test classes. And this is a great way of getting test coverage, but it doesn't actually test anything. So let's also go and ensure that this works. So what we can do is we can query the list of cases, and we'll select the ID from the case where the Jira issue ID is not equal null. Let's go ahead and assert that the size is greater than 0. And if it is 0, then no cases were created, so that's a problem. So let's go ahead and run this test class to confirm that everything works as expected. And you can see that our batch method works as expected. So now we can create a test class for the Queueable method. Let's annotate it as isTest, CLData equals false. And we'll make a static void test Queueable method. We once again need to set the mock as our mock interface. So we'll say test.setMock, HTTP callout mock.class equals new mock. Then we want to create a new queueable. So we'll say Jira issue queueable, queueable equals new Jira issue queueable, and we'll put in some parameters. So 0, 0, 50, and 0. Then inside a test block, we can enqueue the new queueable. We can end the test block. And once again, we can do some lazy tests and say that the queueable does not equal null. But let's also go ahead and add a real test case in. So we'll say the list of cases, case list equals select ID from the list of cases, where the Jira issue ID does not equal null, similar to what we had for the batch class. And we can assert that the list size is also greater than 0. So let's go ahead and deploy this and run it to confirm that everything is working as expected. So we are getting an error. It says maximum stack depth has been reached. And so it sounds like we're missing some sort of condition. And so something's not right in the code. And that something is that the current count was not being incremented. It was the total count that was getting incremented. So let's change this to current count, deploy this to Salesforce, go ahead and run this. And now you can see our test queuable is working as expected. So let's go ahead and wrap this up by committing the code. So we'll add all of the code and we'll give it a nice commit message. And we'll push this to GitHub. So that's all the base code written. And if you are using an org-based development, so you just deployed this to the actual org that you're using, then you can deploy this as is. But I want to show how you can use package deployment to actually containerize your code. And so what we're going to do is inside the package.xml, we're going to update a few things to pull from Salesforce. So first of all, we'll update the version to the latest version at this time. And then we'll add some types based on what we actually need to pull from Salesforce. So first of all, we need to pull over some custom fields. And so the syntax is each member has the object name and then the field name. And this is for custom fields. We want to bring over that permission set that we created. We want to bring over the quick actions we created. And we want to bring over the custom link, which is called a web link. And we want to bring over the external credential. And we want to bring over the named credential. So now what we can do is right click inside the package.xml. Keep in mind this needs to be in the manifest/package.xml. We can retrieve the source from Salesforce and we do have an error. Looks like I had an extra field from my light version, but let's go ahead and retrieve this. And you can see a lot of fields were created. So if we open the directory, you can see we have now the external credential, we have the named credential, we have various custom fields, and we can actually package all of this. Now, because we're packaging this, I actually want to do a few things. We're going to change the Force app to Jira Integration because I think it's more descriptive of what's going on. We also want to split up this into two parts. So we want a core package, which is all of the code, and we want an auth package, which is all of the stuff related for the authentication. And the reason why we do this is because the unlocked packages that we'll use will actually overwrite anything. And so if you update this in the future, then the auth will actually get reset, which is not what we want. So let's go ahead and drag all of that auth stuff into the auth directory. So that'll be the permission set, the named credential, the external credential, and then everything else can stay in core. One of the requirements for an unlocked package is a DevHub organization. So what we can do is inside of setup, go to DevHub and enable DevHub. And additionally, we want to enable unlocked packages and second generation managed packages. Then back inside in VS Code, we can go and authorize a DevHub org, which can be the same org we just created. So that'll take us to the UI and we'll confirm the authentication successful. And now we can use this org as a dev hub. So to create a package, we can use this command where we pass in a name and a path, and we pass in the package type of unlocked. And if we go down to the sfdx project JSON, we can actually see that this updated with this package directory. And maybe we can also update this name to be more descriptive. As well, we can remove the original boilerplate code. Now, because we split this into two packages, we'll go and make a core package as well. And you can already see how this package updated. And for more information about unlocked packages, I did make a video, so check that in the card above. Now we can use this command here to create a version where we pass in the package ID. And critically, we use this -x flag to go and run test code, which will allow us to promote it to production and eventually install in production orgs. You can see the package ID is returned, which we can use to promote this. Promotion is the idea of selecting the package as a way of installing in production. So what we'll do is we'll basically run the same command, but we will use the promote. We'll confirm with yes, and you can see that this is ready to go and be installed. For our core package, we want to do the same thing where we use the sf package version create, but we use this core ID. So the previous package didn't have any Apex code, so we didn't need to worry about test coverage, but this one does. And so what we can do is we can take the package version ID and we can run the command sf package version report and pass in the package ID as a flag. And you can see this is a general information about this, but specifically we have the code coverage flag, and the code coverage met is true, which means this is eligible to go and promote. So let's go ahead and run the promote command here. And that's everything. So you can now go and install this in any production org. If you enjoyed this tutorial, let me know by leaving a comment down below if you made it this far. So thanks and have a good day.